In this video, we're going over the memorization approach of best time to buy and sell stock for. So previously in the recursive approach, we have gotten our TOE error, and now we're going to optimize it. So let's go over the thought process. So in the recursive approach, the solution is not efficient enough due to overlapping recursive calls. We can avoid overlapping recursive calls using memorization. Now, what do we need to cache? In each of the recursive call, we are trying to find the maximum profit at the current the current states, and the number of transactions. This means we can cache ISK with maximum profit. Now let's go over the pseudocode. So we're going to create a 3D matrix Memo to cache previously calculated results. So the x-axis represents I, the y-axis represents S, and the z-axis represents the number of transactions, which is K, and then the values represents profit. And then we're going to fill Memo with -1. This is to prevent the side case where we can get no profit from the input array. Then we're going to implement the top-down memorization approach. We're going to pass in our Memo, which is our cache. And then what's the base case? So we still have a base case. If I is out of bound, there are no more stocks to process, or K is equal to 0, which means that we can perform no more transactions. So when the maximum profit we can get is 0. So return 0 here. Now we also have if Memo ISK is not equal to -1. This means we have already calculated the results for the current parameters. Then we're going to return the cache results. Then each of the recursive column, if our state is equal to 0, we're currently in the buy state. We're going to recursively find the profit if we buy the current stock. So we move it forward, move our index forward, and our state go to 1, which is our sell state. And then we're going to recursively find the profit P2 if we skip the current stock, which is just moving our index forward. And then we're going to return the maximum value of buying the current stock or skipping the current stock. But before we return it, we want to save it. And then we can return the saved results. Else we're currently in sell state. So we're going to recursively find the profit if we sell at the current price. So we move our index forward, our states go back to 0 because we have sold currently. And then the number of transactions we have left decrements by 1. Then we're going to recursively find the profit if we skip the current price, which is just moving our index forward. And then we want to return the maximum profit between selling at the current price or just skipping the current price. But before we return it, we want to save it. Then we're going to return the cache results. Now what's the time and space complexity? For the time complexity, we get O of n times k times 2. Which is equal to O of nk. Where n is the length of the input array, and k is the input value, is the number of transactions. This is filling Memo with -1, and then each recursive call has nk2 states, or n times k times 2 states, with the number of transactions, and also the current state. In our space complexity, we get the recursive call stack memory and also the Memo. So we get O of nk, which is the Memo. Now let's go over the code. So we're first going to create our Memo. So we get prices.length, the number of transactions. Do we put state here? We put states instead. So we get 3 because, we get 2 because it's 0 and 1. And also the number of transactions is k plus 1 because we want 0 to k. Then we're going to pass in our Memo. We want to fill Memo of -1. Then we're going to implement our top-down memorization approach. Pass it in our Memo. Go over the 2 base cases where we can no longer generate any profit. And then we also have if Memo ISK is not equal to -1, then we can just return the cache results. And then if our state is equal to 0, we're currently at the buy states. We want to find the maximum profit between buying at the current price or just skipping the current price. But before we return it, we're going to save it. And also, if currently our sell states, we want to find the maximum profit between selling at the current price or just skipping the current price. But before we return it, we also want to save the results. Do not forget to pass in our Memo into our other recursive calls. Let me know if any questions in the comment section below.